Okay. Good afternoon, friends. Welcome to the IC Gate. Today we are going to discuss a very important topic, that is the basics of SOM, where we will discuss that what is the meaning of strength of material, then from where it came, and then we will discuss that what is the aim of strength of material. Okay, and after that we will explain the stress strain diagram that is very important for all of the students for mechanical and civil engineering. Okay, and at last we will solve few recent gate questions. Okay, so should we start? Am I audible to all? Okay, fine. Okay, so first of all I will tell you that if, especially for strength of material subject, if you know the formula of the strength of material, but you forgot the concept of this subject, then definitely you won't be able to solve the question of this particular subject. For other subject, it is okay. For other subject, if you know the formula, if you forget the concept, then definitely by any means you can apply the formula and you can have the answer of that questions. But for strength of material, the basic understanding of the basics of the SOM, that is stress, the strain and all these things, that is very important. So today, first of all, I'll focus on the basics of strength of material, then I will explain one by one, and then at last we will discuss the very important thing, that is stress strain diagram. Okay, fine. Okay, so first of all I will tell you that from where the subject strength of material came. Okay, so if I'll talk about, suppose there is an object, and if I am applying a load, if there is an object and I am applying an external load or force, you can say, okay, either load or force. So can you tell me that what is the basic difference between load and force? Okay, so load means an external force or couple acting on a body when body is functioning. So load may be either force or couple. So if I'm talking about the load, it means it may be either force or couple. So suppose if there is an object and an external load is acting on this object, then the effect of that load on this object, that we will study in a particular topic, that is mechanics. Okay, it means suppose I am taking an object. Till now I didn't tell you that which type of object it is. Okay, so in mechanics subject we have to deal with the load or force. Okay, in mechanics subject we have to deal with the load or force, and here we did not fix the type of object, because as you know there are mainly three types of object is there. The first one you can say here, the first one you will have solid, then liquid, then gas. Okay, the object may be either solid or liquid or gas. So when I was telling this, I was explaining the concept of mechanics, then one student asked me, okay sir, suppose here I am fixing the object, here I am taking the object as a solid, then what will happen? Are you getting me? अगर मैं object, solid object fix कर रहा हूँ, in that condition what will happen? Then I told him, if you are talking about the solid object, then in solid object you may have two type of solid object. The first one is The first one will be your rigid solid, and the second one that you will have deformable solid. Okay, so I asked him, first tell me that in this solid, which solid you are considering here? Then he told me, sir, I am taking rigid solid. Are you getting me? So I told him, if you are considering the rigid object, and you are applying external load or force on that rigid object, then the effect of that external load or force on the rigid object, that you will study in your engineering mechanics. It means in engineering mechanics subject, we have to deal with the rigid object, okay, and we have to deal with external force or load. Okay, it means in entire engineering mechanics subject, you won't find any deformable solid. You always find a rigid solid. Okay. So again, that student asked me, sir, suppose this time I am taking deformable object. Then what will happen? Then I told him, if you are considering object is your deformable object, then the internal resisting load or force, applied on a deformable body, that we have to discuss in a very important subject, that is your SOM. It means in strength of material subject, we have to deal with the deformable object, as well as we have to deal with the internal resisting force here. Here I am writing internal resisting force. Okay, so here we saw that your object is rigid and your force is external force. Here your object is deformable, okay, and your force is internal resisting force. Later I will explain you that why we have considered here external force and why we have taken here internal resisting force. Okay, now that student again asked me, sir, solid it is okay, what about if you are considering liquid or gas? Then I told him, liquid and gas both can be treated as a fluid. Okay, so fluid means fluid which can flow. So liquid or gas दोनों flow कर सकता है. So we will say that liquid and gas both will be your fluid. Okay, fine. So suppose if I am considering liquid or gas, it means we can say we are considering fluid as an object. Then if your object is fluid and you are applying an external load or force, then the effect of that force or load on the fluid, that you will study in your fluid mechanics. Okay, so if anyone will ask you, first tell me that from where SOM came, then you will say that the important thing is mechanics, and engineering mechanics, strength of material and fluid mechanics, all are the part of simple mechanics. Okay, and you may have seen SOM is also known as MOM. MOM means mechanics of material. Another name is MOS, mechanics of solid. So if we'll talk about the specially subject strength of material, then we will say that in strength of material we have to deal with the deformable object as well as internal resisting force. Clear? It means we can say that the internal resisting force applied on the deformable body and the effect of that internal resisting force on that deformable body, that we have to discuss in strength of material. Okay, so fine. After discussing all these things, that student again asked me, ठीक है, चाहत पूरी नहीं होती जल्दी, बार बार पूछे जा रहा. So he again asked me, sir, as we know that for any material, for any object, there will be two limit of the object. The first one will be your elastic limit, and the second one, that will be your plastic limit. It means, suppose if I am taking an object, then you may have two type of limit of that object. That will be your elastic limit, and the second one, that will be your plastic limit. So that student asked me, sir, suppose your deformation is in this limit, elastic limit, then what will happen? Then I told him, if your deformation is in elastic limit or within inelastic limit, then we will say that that effect we will study in theory of elasticity. Okay, got it? So if the deformation is within elastic limit, then that effect that we will study in theory of elasticity. And if that deformation is, or deformation will be beyond the elastic limit, it means in plastic limit, in that condition we will say that that effect that you will study in your theory of plasticity. And I think you all have seen that in the strength of material subject you always use Young's modulus, E and all. So here we are focusing on this theory only. We study only theory of elasticity. So from this diagram you can have an idea that what is strength of material. Okay, so if anyone will ask you that what is strength of material, then you can tell them, you can tell him, sir, strength of material means the effect of internal resisting force applied on a deformable body, that is your simply strength of material. Got it? Now, as earlier I told you that I will tell you that why here in engineering mechanics we are considering external force, and here in SOM we are considering internal resisting force. So I will say that suppose you have two person. The first one is Mr. X, okay, and the second one is the great खली पता होगा ना सबको, ठीक है? And अच्छा बना थोड़ा सा, या सही है, okay, and another person, that is your Mr. Y. And the weight of this person is suppose 50 kg. Okay, so if I will say that Mr. Y will punch Mr. X and Mr. Khali, यानी Mr. Y जो हैं दोनों को पंच करेंगे, Mr. X को भी करेंगे and Khali को भी करेंगे. Listen here, Mr. X, I am taking Mr. X as a deformable object. I am taking Mr. X as a deformable object and Mr. Khali as a rigid object with respect to this Mr. Y punch. यानी जब Mr. Y punch मारेंगे उनके लिए Mr. X will be treated as deformable object and the great Khali will be treated as a rigid body. So if Mr. Y will punch to both, in that condition we can't know the internal resisting capacity of the Khali. अगर एक 50 kg का कोई पर्सन मिस्टर खली को पंच करेगा तो उनकी इंटरनल रेजिस्टिंग कैपेसिटी कितनी है, दैट वी कांट नो, बट फॉर मिस्टर एक्स वी कैन इजीली नो that what will be the internal resisting capacity of the Mr. X. So if the object will be deformable, so in that condition always we have to consider internal resisting force. Got it? That's why in strength of material subject we consider force as an internal resisting force. Clear? So this is the basic of strength of material, that from where SOM came and what is the meaning of strength of material. So if you want to write, then note down all these things, please. Okay, done. So till now we have discussed that what is the meaning of strength of material, and now we are going to discuss that what is the aim of strength of material. In this subject, what we have to think or what we have to focus on. As I told you, in this subject, the basic understanding is very, very important. Because once you will able to identify the type of load acting on the object, and then accordingly you will identify that which type of stress will be produced. Okay? So now we will discuss that what is the aim of strength of material. Okay? So if I will write aim of strength of material, then I will say that the main aim of strength of material is to find or to calculate or to determine the value of stress or strain or relationship between both. यानी जो सोम का मेन एम है वो क्या है? स्ट्रेस, स्ट्रेन और दोनों के बीच का रिलेशनशिप को फाइंड करना. Why? Because we know that if we want to design any object, then first of all we should know the value of maximum stress acting on that object. Once we will have the maximum stress acting on that object, then accordingly we can save the material or we can save the object. So here stress is very, very important. Stress is very, very important topic for all these things. Okay? So as we discussed that the main aim of SOM is to find or to calculate the value of stress or strain or relationship between both. So first of all we will know that what is stress. What is stress? Can anyone tell me that what is stress? Anyone please? Listen, after clearing your gate examination, if you will have good score, then definitely you will go for your PSU's interview, or you can also go for ISRO and BARC interview. And definitely if you will tell them, okay, sir, my favorite subject is SOM, then the first question will be your, what is stress? So please listen carefully. Okay? So now we are going to discuss that, what is stress. Fine? Okay. So if I talk about the stress, then I'll say that stress means internal resisting force applied on a particular area. Stress means internal resisting force applied on a particular area. Why internal resisting? That we have discussed with Mr. X, Y and Khali. Okay? Because here the object is your deformable object. Clear? So if I talk about the unit of stress, then you will say that the unit of stress will be your Newton per meter square. And we also know that pressure is having the same unit as of stress. So definitely you may have a question, sir, what is the basic difference between stress and pressure? What is the basic difference between stress and pressure? Both unit will be same. Okay? And we also know that pressure is associated with the fluid. Always whenever you will have fluid, then in that condition only you will have the pressure. Okay? So here if I will differentiate stress and pressure, then I will say that the first one is, listen carefully guys, because this is very, very important thing. Because once you will know the basic difference between pressure and stress, then you will be able to identify, you will be able to know that what is the aim of strength of material. Okay? So here first one that we will say is, stress is an internal phenomena. Why? Because we know that we have already discussed that here internal resisting force or internal resisting load is acting. But if we'll talk about the pressure, then you will say that pressure will be your external phenomena. Okay? Fine? So the first difference will be your stress will be your internal phenomena and pressure will be your external phenomena. Next. The second difference will be pressure will be your scalar quantity. Pressure will be your scalar quantity, while stress will be your tensor quantity. So first of all, we should know that why pressure is a scalar quantity. So for that, I'll tell you that there was a famous scientist whose name was Pascal, and he told that suppose if there is a fluid, then at a particular point, the intensity of the pressure in all direction will be same. So if the intensity of the pressure in every direction is same, then why we have to bother about the direction of the pressure, direction of the quantity? That's why we will consider that pressure will be your scalar quantity. Scalar quantity means the quantity which require magnitude for its representation. Okay? And the quantity which require magnitude as well as direction for its representation, then we will say that that quantity will be your vector quantity. But now, for stress, it is a tensor quantity. What is tensor quantity? Tensor quantity means, suppose if there is an object, particularly suppose this is P load is acting on this. So you will find that at a particular point, if you will find the stress, then at a particular point you may have one normal stress as well as one shear stress. It means for stress at a particular point you will have two values in two different directions. Are you getting me? So if you will have two magnitude and two direction at a particular point, so that quantity will be known as tensor quantity. It means tensor quantity is an extended form of vector quantity which require more than one direction. इसका मतलब क्या है कि टेंसर का मतलब ये है सर कि अगर किसी क्वांटिटी को रिप्रेजेंट करने के लिए वी रिक्वायर मोर देन वन डायरेक्शन, लाइक यहाँ पे एक ही पॉइंट पे ये भी और ये भी दो वैल्यू. सो दिस टाइप ऑफ क्वांटिटी वी विल से that will be your tensor quantity. जैसे कि और क्या चीज है, you can say strain will also be a tensor quantity. Okay, anything else? Moment of inertia also you can say. Okay, now so till now we have discussed two differentiation between pressure and stress. Now the third difference is very important, guys, so please listen carefully. Third difference, for measurement of the pressure we have many devices. Like if you want to measure the value of stress, then you can use either piezometer, you can use either manometer. It means you can measure the pressure, measurable. But if you will talk about the stress, then in whole universe you can say there is no such device by which you can measure the value of stress. दुनिया में ऐसी कोई डिवाइस नहीं है जिससे आप स्ट्रेस को मेजर कर सकते हो. But we know that stress is very important topic. Stress is very important concept. Why? Because if we want to design any object, then we require the maximum stress acting on that object. So for that, stress is compulsory. Okay, but there is no such device in whole universe by which we can measure the value of stress. Then what we will do? So उसके लिए लोग पढ़ते हैं strength of material. Okay, are you getting me? It means because in whole universe there is no such device by which we can measure the value of stress. That's why we study strength of material. It means the aim of strength of material that I have already discussed is to find the value of stress or strain or relationship between both. Okay, got it? It means till now we have discussed that what is strength of material, from where it came, and what is the main aim of strength of material. Got it? Now we are going to discuss another very important topic, that is your stress versus strain diagram. And we know that suppose if you are a mechanical engineer, then definitely stress versus strain diagram you will have in your SOM subject, machine design subject, as well as manufacturing also. And for civil engineers you may have in strength of material, structural analysis, and RCC and steel also. So the stress versus strain diagram, ये हो गया पूरा? Okay, fine. So now we are going to discuss a very important topic, because if you see the GATE paper, then you will find that in last 4 to 5 years, every time the GATE is asking a simple question, either 1 mark question or 2 mark question from this stress strain diagram. Okay, so now we are going to discuss stress versus strain, or stress strain diagram you can say. Stress and strain diagram. Okay, fine. So one thing I will tell you here, for stress and strain diagram, if you will refer 4 to 5 books, then definitely in every books you will have a different diagram. Okay, but today whatever we are going to discuss, that is the best. ठीक है, जो अभी तक आपने जो पढ़ा वो सब छोड़ो उसको, अभी जो हम डिस्कस करने जा रहे हैं that is your best, because in this diagram we will discuss few topics that you won't find in any book. कुछ टॉपिक हम ऐसे डिस्कस करेंगे, कुछ पॉइंट्स ऐसे डिस्कस करेंगे जो आपको किसी भी पूरे इंडिया के या पूरे दुनिया की किसी बुक में नहीं मिलेंगे. ठीक है? नाउ फाइन. सो इफ आई टॉक अबाउट द स्ट्रेस स्ट्रेन डायग्राम, then I will say that in actual stress and strain diagram does not exist. मतलब stress और strain diagram exist नहीं करता actual में. What is this, sir? I am just telling you, आप मुझे बताना. Suppose if you are making a curve like that, so first question is how you can make this curve. Then you will say that, sir, suppose if we are having all these points, suppose if we are having all these points, it means on this point we know the value of x and y, x and y, x and y, x and y. Then if we will connect all these points, then we will have this curve. Simple. अगर सारे points मुझे पता है, तो after connecting all the points you will have a curve on xy diagram. Simple. But if you will talk about the stress versus strain diagram, so you require a particular points. बहुत सारे points चाहिए आपको, और जब points मिलेगा तभी आप you can connect all these points. But we already discussed that in whole universe there is no such device by which you can measure the value of stress. Then how you can calculate the value of stress at various points? Are you getting me? जब stress को measure करना impossible है, तो कैसे आप हर point पे stress और strain की value calculate कर सकते हो? But sir, how we will study stress and diagram? Because stress strain diagram is very important diagram. Then I will say that for finding the stress strain diagram, people went on UTM machine, universal testing machine, and at that time people took दिस एज एन स्पेसिमन, एक स्पेसिमन कुछ ऐसा लिया, ठीक है, इसको बोला जाता है डॉग बोन, कुत्ते की हड्डी जैसी है ना, डॉग बोन, ओके, एंड दिस विल बी योर गेज लेंथ एंड दिस विल बी योर डायमीटर. जनरली the length of this specimen should be more than 4 times of the diameter. Okay, the length of the specimen should be more than 4 times the diameter. Then people, क्या लोगों ने क्या किया, लोगों ने इस स्पेसिमन को लेकर यूटीएम मशीन पे टेंसाइल टेस्ट किया. People did tensile testing with the help of this specimen. Okay, first one more thing, अगर इस स्पेसिमन का क्रॉस सेक्शन क्या होगा, सो आई विल से दैट द क्रॉस सेक्शन ऑफ दिस स्पेसिमन, वी आर मेन फोकसिंग ऑन दिस, द क्रॉस सेक्शन ऑफ दिस स्पेसिमन विल बी योर सर्कुलर. ठीक है, इट मीन्स द होल स्पेसिमन विल बी योर सिलिंड्रिकल ऑब्जेक्ट. आर यू गेटिंग मी? सो नाउ ऑन दैट बेसिस people draw a load versus deformation diagram, a load versus deformation diagram, because that you can have no problem. On UTM machine you have to apply a particular load, okay, with the help of dial gauge, and on that basis you can find the value of deformation. आप लोड अप्लाई करोगे और आपको डिफॉर्मेशन वहां पे मिल जाएगा. सो फॉर दिस डायग्राम यू कैन हैव अ कर्व. आ रही बात समझ में? सो इफ आई ड्रॉ द स्ट्रेस, सॉरी, लोड वर्सेस डिफॉर्मेशन कर्व, देन आई विल से दैट द लोड वर्सेस डिफॉर्मेशन कर्व विल बी लाइक दैट. दिस विल बी योर लीनियर O A, then this is your curve B, A to B curve, then C D E then F and the G. This will be your load versus deformation diagram. But for which material? Cross section we have fixed, okay. Now for which material, ये किस मटेरियल के लिए कर्व होगा? Can anyone tell me? For load versus deformation diagram, we always took specimen as a mild steel, and mild steel is also known as low carbon steel. Low carbon steel or mild steel. So now the question come, why we always take mild steel as a specimen for the load versus deformation diagram? Then I will say that for mild steel only you will have all these points. ये जितने सारे points आ रहे हैं A, B, C, D, E, F, G, ये सारे के सारे points you will have when you will take mild steel as a specimen. If you take aluminium, if you take some other material, then definitely you may have more than 2 or 3. Max to max you will have 2 or 3 points, nothing else. So for knowing all these points, we always take mild steel as a specimen. Then now again there may be a question, sir, if you want to know the load versus deformation diagram, then why you are going for tensile test? Why not compression test? Why not shear test? Then I will say that again same thing. If you will go for the compression test for the of mild steel or torsion test of mild steel, then in that condition also you won't have all these points, and each and every points have a particular specific meaning. तो इसका मतलब ये है simply कि if you will go for tensile testing of mild steel, then and then only you can have all these points A, B, C, D, E, F and G. Are you getting me? So now till now we have fixed that we are considering mild steel as a material, we are considering cylindrical object, Okay, and we are considering tensile test. Now after that we will discuss all these points. And don't forget, our aim is to find stress versus strain diagram or stress and strain diagram. But till now we are studying load versus deformation diagram. Then people say, sir, this diagram we can get from tensile testing. Now, if we want to find the stress versus strain diagram, then what will happen? If we'll talk about the stress, then we know that sigma is equal to P by area. Okay? And this is average stress. Because there was a famous scientist whose name was Saint Venant, and he had done an experiment, and he told that suppose if you are taking this object and you are applying a load on this object, and if you will calculate the value of the stress at this point, then you won't get P by A, average stress, because at this section you will have a stress like it means here the maximum stress will be your 1.38 something sigma average, and P by A is your sigma average. And on that basis Saint Venant told that if you want to know the sigma average, it means you want to develop stress, same stress is equal to P by A on every point on this cross section, then you have to consider the cross section, you have to consider the point here in between both the ends. Okay, so if you will consider this section, then at every point you will have same stress, that will be your P by A. So it means sigma is equal to P by A, and we also know that strain is equal to delta upon L. It means deformation upon original length, that will be your strain. So on that basis, if we want to draw a stress versus strain diagram, then I will say that here I will divide pressure by area, and here I will divide deformation by length. So here we will have strain and here we will have strain. But you know, if you will divide anything, then definitely that quantity will reduce. तो जैसे आप डिवाइड करोगे, आपका जो डायग्राम होगा वो ऐसा नहीं होगा. Your diagram will be like that. डायग्राम आपका कुछ छोटा हो जाएगा. Are you getting me? But for explanation, I am considering this as a stress versus strain diagram. But you should know the basic concept, that if you will convert the load versus deformation diagram into stress versus strain diagram, then you will have the smaller one. जो छोटा वाला डायग्राम है वो आपका होगा स्ट्रेस वर्सेस स्ट्रेन डायग्राम. बट फॉर स्टडी पर्पस I am considering this as a stress versus strain diagram. Okay, fine. So now I will write the name of all the points here. So here O, origin you can say, A, proportional limit, B, elastic limit, C, upper yield point. That is very important point. Okay, the explanation of upper yield point you won't find anywhere, so remember that. D, lower yield point. Then D to E, that will be your perfectly plastic region. Then E to F will be your strain hardening region. F will be your ultimate point, and at last G will be your fracture point. So the name of all the points I have written there. O is origin, A proportional limit. From O to A, this is a straight line, okay? And A to B, this is simple curve. B to C curve, D to C to D, E, F and G, okay? So now all these points, okay, fine. Now I am going to explain each and every point here, okay? So should we start? Okay, fine. So first of all, you all have studied Hooke's law. So can you tell me that what is Hooke's law? As you have studied that, Hooke was the first scientist that researched on elastic properties of the material, okay? So on that basis, he told that stress is directly proportional to strain. हुक सबसे पहले साइंटिस्ट थे जिन्होंने रिसर्च किया था इलास्टिक प्रॉपर्टीज, मटेरियल की इलास्टिक प्रॉपर्टीज पे, एंड ऑन दैट बेसिस ही टोल्ड दैट स्ट्रेस विल बी डायरेक्टली प्रोपोर्शनल टू स्ट्रेन. बट उन्होंने आगे कुछ नहीं बताया था. And we know that stress is directly proportional to strain, and if you take the proportionality constant, that will be your capital E, then you will say that stress is equal to E into epsilon. And that is given by a famous scientist whose name was Thomas Youngs in 1807. 1807 में थॉमस यंग ने उनका कॉन्सेप्ट लेकर बताया कि द प्रोपोर्शनलिटी कांस्टेंट हियर विल बी कैपिटल ई, एंड लेटर द कैपिटल ई इज नोन एज यंग्स मॉडुलस. तो इनके नाम पे यंग्स मॉडुलस बोला गया. ओके, फाइन. सो फ्रॉम हियर यू कैन से दैट stress is directly proportional to strain, and in some of book you will find that stress is directly proportional to strain up to elastic limit. That is wrong. Okay, why? I will prove later. Okay, so here I will discuss that stress is directly proportional to strain. Stress is directly proportional to strain up to proportional limit. It means this point, A point, proportional limit. It means from O to A, stress will be directly proportional to strain. Why? Because if I will make a line on y and x axis, then if I'll ask that what will be the equation of this line, then you will say that, sir, this equation will be y directly proportional to x or y is equal to mx. Why? Because this is the equation of line where m will be your slope. It means for linear equation, for linear dimension, you can say that y is directly proportional to x. So on that basis, here y sigma, x epsilon. So sigma will be directly proportional to epsilon up to point P, up to point A. क्यों? क्योंकि O से लेकर A तक हमारा एक लाइन का इक्वेशन, एक लाइन है. But if we will consider this point B, as I told you, na, in many of books you will find that stress is directly proportional to strain up to elastic point. That is wrong. Why? Because from point A to B, that is curve, and y directly proportional to x, that you can't apply for a curve line. अगर आपके पास कर्व लाइन है तो y directly proportional to x, यानी ये जो लाइन का इक्वेशन है, that you can't use there. So we will say that O to A, stress will be directly proportional to strain. It means A will be your proportional limit. Now, if we will go for A to B, B means elastic limit, elastic point. B means elastic point. What is the meaning of elastic point? Suppose if you are applying a load on the object up to this point, and when you will remove that load, then definitely your body will regain its original position. यानी कि जैसे आप यहाँ तक अप्लाई करते हो स्ट्रेस ऑब्जेक्ट पे, एंड व्हेन यू रिमूव द लोड, तो आपका पूरा का पूरा ऑब्जेक्ट सेम उसी पोजीशन पे ओरिजिनल अपने पॉइंट पे आ जाएगा. Okay, but if we will apply the load beyond this point B, इसका मतलब ये हमारा इलास्टिक है, इलास्टिक लिमिट है, इलास्टिक लिमिट के अंदर कोई भी ऑब्जेक्ट, then no problem, the object will regain its original position. But beyond the elastic limit there will be plastic deformation, there will be a permanent deformation. Are you getting me? So point B is elastic limit. Till now if you are applying load, okay, no problem, but when you will remove the load, the object will regain its original dimension, original position. Now the point C is your upper yield point, that I will explain later because this is very important. Practically there is no significance of this point, and D is your lower yield point. In all the objects you will have only one yield point, okay, but for mild steel only you will have two yield point due to its crystalline arrangement. जो इसका माइक्रोस्कोप लेवल पे यानी कि एटॉमिक लेवल पे जो इसका स्ट्रक्चर है, on that basis only you will have two yield point, but for all the materials, all other materials, you will have only one yield point. What is the meaning of yield? Yield means, this is your yield point, the main yield point. Yield means at the same load or stress, you will have a permanent, you will have an appreciable deformation or strain. यानी कि same stress पे you will have an appreciable strain at the same load. आ रही बात समझ में? यानी कि अगर आपको डिफॉर्मेशन चाहिए, so for further deformation or for further strain you are not increasing the value of stress or load. So this will be your D and E will be your perfectly plastic. Why its name is perfectly plastic? Because in this section from D to E, suppose this is your object, okay, and if you are applying tensile load on this object, then here definitely after point D there will be decrease in diameter and there will also be an increase in length. अगर कोई चीज खींचोगे आप तो diameter छोटा होगा, length बड़ा होगा, and in that region from D to E the proportion of decrement of diameter and the proportion of the increment of length will be same. That's why we said that D will be your perfectly plastic. आ रही बात समझ में? D रीजन में क्या होगा? जिस proportion से diameter कम हो रहा है, same उसी proportion से length will increase. So we will say that your point D to E region will be your perfectly plastic. Now from E to F will be your strain hardening. Strain hardening means, as its name suggests, strain hardening. Due to straining, the hardness of the material will improve. It means from E to F there will be grain refinement. Okay, atomic और crystalline का structure change होगा. So after grain refinement, the hardness of the object will be high. So for further deformation or for further load, you will require more stress. यानी अगर आपको इसके बाद अगर यहाँ पे इतना deformation चाहिए after this point, तो you will have to apply a more stress. इतना ज़्यादा stress आपको apply करना पड़ेगा, ठीक है? Now from E to F you will have strain hardening. Okay. Now F is your ultimate point. And guys, listen, this is your engineering stress versus strain diagram. This is not your true stress versus true strain diagram. So after point F is your maximum ultimate point. Okay, maximum load on this object that you can apply in engineering stress versus strain curve that you will have, that will be your ultimate point. And from F to G, it will be your necking region. Necking region means from point F to G there will be necking formation. Object में necking formation start हो जाएगा जिससे उसका area बहुत कम होने लगेगा. And G will be your fracture point. Okay? Fracture means at this point your object will rupture. Your object will fall. Okay? So again I am repeating the same things from O to A, proportional. It means linear equation. Okay, A to B curve up to point B, that will be your elastic limit. B to C, sorry, C point, upper yield point, D point, lower yield point, D to E, perfectly plastic, E to F, strain hardening or grain refinement zone, and F to G, necking. F is your ultimate point and G will be your fracture point. Okay, so just note down all these things. Okay, fine. So I got a doubt. A student asked me that, sir, what do you mean by the term elastic properties? Then I'll tell you that in next lecture you will have this. Elastic properties means, suppose here stress is directly proportional to strain. So if you use the proportionality constant, then that will be your capital E. So here you will say that your capital E will be your elastic property. Elastic property means the property which show a particular relationship between stress versus strain. यानी जो भी प्रॉपर्टी जैसे स्ट्रेस और स्ट्रेन के बीच में रिलेशनशिप बताएगी, दैट विल बी योर इलास्टिक प्रॉपर्टीज. लाइक सिग्मा इज इक्वल टू ई राइट, एंड आफ्टर सम टाइम यू विल हैव थ्री टाइप ऑफ इक्वेशन, 2g 1 plus mu, E is equal to 3k 1 minus 2 mu, E is equal to 9 kg अपॉन, ये सारे के सारे प्रॉपर्टी, E हो गया, G, mu, K, ये सारे के सारे क्या इलास्टिक कांस्टेंट है. व्हाई? बिकॉज इट विल शो अ रिलेशनशिप, इट विल टेल यू द रिलेशनशिप बिटवीन स्ट्रेस एंड स्ट्रेन. जैसे यहाँ पे हुआ, इफ विल टॉक अबाउट द टाउ डायरेक्टली प्रोपोर्शनल टू shear strain, shear stress डायरेक्टली प्रोपोर्शनल shear strain, in that case condition you will have G. आ रही बात समझ में? ओके, सो इलास्टिक कांस्टेंट मीन्स सिंपली the relationship between stress and strain. Okay, fine. Should we start? Okay, so I already told you that I will explain you that what is the physical significance of the point C, that means your upper yield point. So here I'll say that for upper yield point, इसको मिटा दूं, for upper yield point I will say that, because anyone can ask this question, sir, suppose if you want this deformation, and one more thing guys please, ये O से लेकर A तक जो deformation है, from O to A and from D to E, from D to E जो deformation है वो O to A का deformation का minimum 10 to 15 times होगा. ठीक है? It means you can say here कि D and E, DE that will be equal to 10 to 15 times of OA. Okay? That's why I made this larger. इसलिए मैंने थोड़ा बड़ा बना दिया. Okay? So अगर आपको इतना deformation चाहिए, then you are applying, suppose if you want this deformation or this strain, you have to apply this load or stress. But for further deformation, suppose this or this, you require less load or less stress. How it can be possible? Are you getting me? इतना deformation के लिए आपको इतना ज़्यादा load चाहिए, but for further deformation you require less stress. So how it can be possible? Then I will say that, sir, for mild steel only, mild steel as an interstitial solid solution of iron carbon. जो mild steel है वो iron carbon का interstitial solid solution है, where there will be iron atom. अगर मॉलिक्यूलर लेवल पे जाओगे तो ये आयरन एटम होगा, and in between this, the space of iron, there will be your carbon atom. Okay, but the space that is required for the carbon atom, जो स्पेस कार्बन एटम के लिए रिक्वायरमेंट होती है फॉर जनरल स्टील, फॉर द केस ऑफ माइल्ड स्टील, दैट स्पेस विल बी वेरी लेस. यानी कार्बन एटम को बैठने के लिए जितनी जगह चाहिए उससे कम हमारा स्पेस होगा फॉर द केस ऑफ माइल्ड स्टील. यानी लो कार्बन स्टील में जो कार्बन के लिए स्पेस होगा दैट विल बी वेरी वेरी लेस. सो एट दिस कंडीशन द कार्बन एटम विल बी, जो कार्बन एटम पूरा का पूरा होगा वो बिल्कुल अनकंफर्टेबली बैठा होगा, और ये पूरे के पूरे एटमॉस्फेयर को बोलते हैं, वी यूज्ड टू से दैट क्रॉटल एटमॉस्फेयर. आर यू गेटिंग मी? यानी फॉर द केस ऑफ माइल्ड स्टील ओनली, फॉर द केस ऑफ लो कार्बन स्टील ओनली, द स्पेस दैट इज रिक्वायर्ड फॉर द कार्बन एटम दैट इज नॉट सफिशिएंट. सो इन दैट कंडीशन जो कार्बन एटम है बहुत अनकंफर्टेबली बैठा हुआ है. It means that atmosphere will be your crottal atmosphere. It means if you want to deform that, then definitely first of all you have to break this atmosphere. जो atmosphere crottal atmosphere बना है उसको पहले आपको तोड़ना पड़ेगा. So this extra, जो इतना एक्स्ट्रा आपका लोड लग रहा है, this extra load you are supplying to break the crottal atmosphere only. Are you getting me? This extra load you are applying to break this atmosphere, and once you will break this atmosphere, then definitely at the same load you will have an appreciable deformation. एक बार जैसे टूट गया आपके पास आराम से ये पॉइंट मिल जाएगा. Now then again the same question will be, sir, for this deformation or strain you are applying this load or stress. इतना deformation के लिए इतना अप्लाई कर रहे हो, and for further deformation or further strain you are applying less amount of load or stress. How it can be possible? Then I will say that here from F to G there will necking take place. There will be necking of the specimen. Necking means decrement of the area. वहाँ पे जो एरिया वो क्या करेगा, डिक्रीज करेगा. इट मीन्स सपोज फॉर एग्जाम्पल हियर योर लोड इज 100 न्यूटन, ओके, एंड हियर योर एरिया, here your load is 100 Newton and the area at this point of the specimen is your 10 meter square. So in that condition you will have stress is equal to 100 upon 10, that means 10 Newton per meter square. Okay, and for beyond this point F definitely there will be necking. So due to necking there will be less the diameter, the area जो होगा पूरा क्या हो जाएगा, थोड़ा कम हो जाएगा. तो ऑब्जेक्ट का एरिया क्या हो जाएगा, कम हो जाएगा. And then suppose the area of the object is suppose 8 meter square, that we already assume 10 meter square here. तो यहाँ पे कहीं पे हमारा 8 meter square एरिया हो गया, and accordingly we are applying a force of, you can say, 90 Newton. Are you getting me? यहाँ पे 100 Newton, but for this point you are applying 90 Newton. So if you will talk about the ratio, here you are applying load 10 times of the area, and here you are applying load more than 10 times of the area. But if you will find the stress at this point, so you will write that, sir, stress at this point will be your load upon area, but here you will consider original area, that is your 10 meter square initial area. Why? Because in engineering stress versus strain curve diagram we always use original area. So here if we will talk about the original area, then the stress will be 9 Newton per meter square, that will be less. इसका मतलब साफ है कि आगे due to necking the area will be less, but for engineering versus strain stress versus strain diagram we consider original area, that's why this curve will be like that. But if you talk about the true stress versus strain diagram, then your curve will be like that. ये बढ़ता जाएगा, पूरा का पूरा आगे बढ़ता जाएगा. Are you getting me? Because in true stress versus strain curve, you have to take original area, you have to take instantaneous area at a particular, at every point you can say. Are you getting me? That why, what is the physical significance of this and this? Here, there was a chrotal atmosphere. So for further deformation, first of all, we have to break the chrotal atmosphere, and for breaking that chrotal atmosphere, we require this more load or this more stress. Once you will break that chrotal atmosphere, you will have an appreciable deformation or appreciable strain. And here you are taking original area because you are focusing, you are considering engineering stress versus strain diagram. That's why your curve will be like that. Your curve will decrease here from F to G. Clear? Fine. Now, if this diagram is clear to you, then definitely on this basis you can solve many questions, because you know that there may be few questions like in recent GATE examinations. Many times they ask that what is toughness. If they will give you the stress versus strain diagram, then they will say that what will be the toughness value for this case. So here I will tell you strain energy first. Strain energy means, strain energy means, if the name suggests strain energy, if you are applying a load or force on a particular object, then definitely there will be change in the object, जो dimension का change होगा, there will be strain in that object, and due to straining, the energy absorbed by the object, that will be your strain energy. Okay, energy absorbed by the object due to straining, that you will say that will be your strain energy. Now, so if you want to find the value of strain energy, then you have to take, because as we know that strain energy means 1 by 2 into P into delta. From where it came, that I will explain in next classes. Okay, so strain energy is equal to 1 by 2 into P into delta. It means if you are focusing load versus deformation diagram like that, and if you want to calculate the value of strain energy, then definitely you just have to find the area of this diagram, 1 by 2 into P into delta, triangle diagram. Here this will be your P, this will be your delta. So on that basis you can find the area of this, and the area of this will be your strain energy. Now the question is, what is resilience? What is resilience? Then I will say that resilience means energy absorbed by the object within elastic limit. Suppose this is your elastic limit, then I will say that elastic limit से पहले किसी भी point पे, यहाँ पे कहीं भी, अगर यहाँ पे है तो ये जो area है वो area केवल, अगर यहाँ पे है this total area, it means we can say that the total energy absorbed by the object within elastic limit, that will be your resilience. Okay, got it? Okay, and if you will find the maximum energy absorbed by the object till this point, elastic limit, then you will say that will be your proof stress. Yani proof stress means same thing, resilience, but here for the proof stress we are taking maximum point, यानी कि पूरा का पूरा area up to, यानी जो elastic limit वाला area है वो पूरा का पूरा area, that will be your proof stress. Getting me? Now, but guys listen here. For strain energy you are focusing on load versus deformation diagram. Okay, but if we'll talk about the stress versus strain diagram, and suppose this is your stress versus strain diagram, this is your elastic limit, then in that condition I will say that strain energy, if you want to calculate, and you are considering same triangle area, 1 by 2 into sigma into epsilon, then here 1 by 2 into sigma means 1 by 2, sigma means P by area, and epsilon means delta upon L. It means 1 by 2 into P into delta upon volume. It means if we will draw the curve on stress versus strain, Okay, so on stress versus strain curve, whatever the area that you will have, that will be your strain energy per unit volume. So if you will find the area on stress versus strain diagram, then you will have strain energy per unit volume, and for this case you will have strain energy only. Okay, is that clear? Okay, fine. So if it is clear to you, then definitely I will just show you the few recent GATE examinations, and definitely if you see the GATE question definitely, then you can have an idea that sir, this will be the answer of this your question. ठीक है ना, कौन से क्वेश्चन का आंसर क्या होगा आप आराम से पता कर पाओगे. ठीक है, so just I am showing you the recent GATE questions. Suppose there is a question in GATE 2014, and the question is, this is your stress versus strain diagram, and he asked about point P, Q, R and S. if point P, Q, R इसके बारे में पूछा है, then definitely we won't have any problem because we have already discussed this points. So definitely we can tell them, sir, the point P will be your proportional, Q will be your elastic point, R will be your upper yield point, and S will be your lower yield point. So this question came in GATE 2014, okay, in mechanical paper. So definitely you can have this. अगर ऐसा क्वेश्चन आएगा तो आराम से सॉल्व कर लोगे. वन मोर क्वेश्चन दैट आई एम टेलिंग यू. There is a very nice question that came in GATE 2018 paper, that is a perfectly elastic plastic. Question is, last question, a perfectly elastic plastic material has a yield stress is equal to 450 megapascal and fractures at a strain of is equal to 0.45, fractures at a strain of 0.45, the ratio of resilience to the toughness, ये हमें फाइंड करना है. हमें क्या फाइंड करना है? ठीक है, हमें फाइंड करना है रेशियो ऑफ रेजिलियंस टू द टफनेस. So first of all, here we should know that what will be the stress versus strain diagram of elastic plastic material. अगर हमारे क्वेश्चन में given elastic plastic material, so what should be the diagram of elastic plastic material? Then I will say that the elastic plastic diagram will be your like that. Okay, this will be your elastic plastic diagram where this will be your yield stress. So it is given 450 megapascal, and the fracture strength, this will be your fracture point. So here it is given that 0.45 strain. Okay, but here asking resilience to the toughness. Resilience means the energy absorbed by the object till or within elastic limit. This will be your elastic limit and this will be your plastic limit. But what is toughness? Toughness means maximum energy absorbed by the object up to fracture point. यानी फ्रैक्चर होने से पहले ऑब्जेक्ट मैक्सिमम कितनी एनर्जी अब्जॉर्ब करता है, दैट विल बी योर toughness. So from here you can calculate the area. Resilience means the area of this only. So here you can say that 1 by 2 into P, 450, 1 by 2 into 450 into this strain. But you don't know the value of this strain. Then how you will find the value? How you will find the value of resilience? But here in question, one more thing is given, that is E. The value of E is given here, 250 megapascal. So what will you do? On the basis of E, you can find this value. Why? Because you know the stress is directly proportional to strain. Sigma is equal to capital E into small e. And from here you can find epsilon is equal to sigma upon E. So for this point, you have sigma, that is 450 into mega means 10 to the power 6. And E is equal to 250 into 10 to the power, sorry, the question is given 4.5 gigapascal, sorry, 4.5 gigapascal. So sigma is 450 into 10 to the power 6 Pascal, and that will be your 4.5 into 10 to the power 9 Pascal. So from here you can have 0.1. So this will be your 0.1. Now definitely you can easily find the value of area of this diagram, and the area of this diagram will be 0.1 by 2 into 450 into 0.1. But for toughness we require the total area, यानी fracture तक पूरा का पूरा area. So for this area we will have the area of triangle plus we will have the area of rectangle. So here we can say 1 by 2 into 450 into 0.1 plus this will be your 450 and then this will be your 0.35. ओके तो इसको जब सॉल्व करोगे तो आपका आंसर आ जाएगा डायरेक्टली. So here the main important thing is you should know that if the question will be for elastic plastic material, then what will be the stress versus strain diagram of elastic plastic material. Once you know the diagram, then definitely no problem, you can solve this. But there may be a doubt, sir, for resilience and for toughness we are considering load versus deformation diagram, but you are taking stress versus strain diagram, then how? Then I will say that don't worry, because resilience you will consider load versus deformation diagram, and if you will consider on stress versus strain diagram, then that will be your toughness per unit volume, and resilience, for the case of resilience, that will be your resilience per unit volume, and volume got cancelled, so definitely there won't be any problem. So if you solve this, and then definitely you can have the answer of this question. Okay, fine. So if further if you have any doubt, then you can ask me on this number 8140 745095, or you can mail me your doubts through mail on rainitz@com. Okay, fine. Thank you.